Kausalya, Assistant Professor from the Department of ECE. Today we are going to see a topic about IoT, logic and physical design. First, physical design of IoT. So, physical design of IoT refers to IoT devices and IoT protocols. Things or node device which have unique identities. It can perform like remote sensing, actuating and monitoring capabilities. Communication established between things and cloud-based server over the internet by various IoT protocols. So, coming to the generic block diagram of IoT. So, there are too many cloud servers available for especially IoT system. So, these are known as IoT platform. First thing is connectivity. So, under connectivity we have USB host and Ethernet, and under processor we have CPU, and under audio video interface we have HDMI and audio and RCA video. Next, under IO interface for sensors we have UART, SPI, I2C, memory, NAND. Under memory we have NAND or NOR. Next, under graphics we have CPU. Under storage interfaces we have SD, MMC and SDIO. Next, what is a protocol? So, IoT protocol help to establish communication between IoT device and cloud-based server over the internet. So, without the protocol, the communication doesn't happen in IoT. So, it helps to send commands to the device and receive data from an IoT device over the internet. So, coming to IoT protocol, we have four type of layers. So, first thing is the application layer, which is given in the diagram. For that, HTTP, COAP, WebSockets, MQTT, XMPP, DDS and AMQP. So, these all the layers comes under application layer, these protocols. Next, under transport layer, the TCP and UDP protocol occurs. So, in the network layer, we have IPv4 and IPv6 and 6 low band. So, these are the protocols for network layer. So, next, coming to link layer, we have 803, 802.3 Ethernet and 802.16 Wi-Fi Max and 802.11 Wi-Fi. Next, LP band. Next is the cellular. Next, coming to logic design. So, logic design refers to abstract representation of the entities and processes with ongoing into the low-level specifiers of the implementation. So, for best understanding logical design of IoT, we describe the given terms. First, IoT functional blocks. Next is IoT communication models. Next is IoT communication APIs. Coming to IoT functional blocks, an IoT system comprises of number of functional blocks that provide the system capabilities for identification, sensing, actuation, communication and management. So, under application we have management, services, communication, security and also the device. The IoT system, we have the number of functional blocks that we are seeing. So, first thing, device means the IoT comprises of the device that provide. What is the device? It means it is the device which will always sense, actuate, monitor data and control functions. Next thing is communication. It handles the communication for IoT system. The next thing is management. It provides various functions to govern the IoT system. So, next is services. So, it provides services for device monitoring, device control safe and device publishing services and service for device discovery. Coming under security system, so it provides authentication and authorization, encryption of data, cyber security and decryption, data integrity and data securities are these. Coming to an application, so there is an interface that the user can use it to control and monitor various aspects of an IoT system. For example, in a smart home application, we use it to control the room LED light fan. So from the user from anywhere. So the user can application allow user to view the system status and view or analyze the processed data. Coming to the next IoT communication model. The first thing is request response model. Next is publish subscribe. Next model push pull model. Next is exclusive pair model. First thing, here is a block diagram for request response communication model. See here the client sends request to the server first and it receives response from the server. So in the server, it happens, it receives requests from the clients, process the data and store the data and prepare response and send the responses to the client. So the client send request to the server responds to the client. Next, these are fall under categories. Next is request response communication model. So already explained, this is a stateless communication model and each request response pair is independent of others. Example, HTTP work as a request response protocol between the client and the server. A web browser, imagine a web browser is a client and an application on a computer that hosts a website may be the server. Example, a client submits an HTTP request to the server, then the server returns a response to the client. The response contains the status information about the request and may also contain the requested content. Coming to the publish subscribe model, it is a communication model that involves publishers, brokers and consumers. Publishers are a source of data. Publishers send message to topics. Publishers send the data to the topics which are managed by the broker. So publisher are not aware of the consumer, but consumer subscribe to the topic which are managed by the broker. So once the broker receives data from a topic or from the publisher, it sends data to all subscribed consumers. Next is a push-pull model. It is a communication model in which data producers push the data to queues and the consumers pull the data from the queues. Queues means it helps in decoupling and the messaging between the producer and the consumer. Producers do not need to be aware of the consumers. Next, queues also act as a buffer which help in situations when there is a mismatch between the rate at which the producers push data and the data at which consumer pull data. Coming to exclusive pair model, so this is a bidirectional fully duplex communication. Fully duplex communication means it both sends and receives the request. So that use a persistent connection between the client and the server. The connection is set up, it remains open until the client sends a request to close the connection. The client and the server both can send messages to each other after the connection is set up. So exclusive pair is a stateful communication. The server is aware of all the open connections. The first thing, the request is to set up a connection. Next, the response accepting the request simply. Next, a message from the client to the server. Next thing, the message from server to client. Next thing, the connection data request. Next, the connection clear response. These are the steps for exclusive pair communication model. The conclusion that the logic and physical design of IoT forms a foundation for building robust, scalable and secure IoT systems. By leveraging appropriate protocol and functional blocks, IoT solutions enable seamless connectivity, reliable data transfer and effective data management. Understanding various communication models such as request response, publish, subscribe, push, pull and exclusive pair allows for flexible, efficient and communication between the IoTs. A strong design strategy is essential for harnessing the full potential IoT technology while ensuring system integrity, security and its performance. So this is the question for us. What is the difference between physical and logical design of IoT? List out the functional blocks of an IoT system and briefly describe their roles. Describe publish subscribe communication model used in IoT. Explain the role of broker. What advantages do push-pull model offer over the request response model in IoT communication? Next, explain how security is implemented as a functional block in IoT systems. Thank you.